Hello, I'm glad to participate on European Conference of Fracture. My name is Selyutina. The topic of my research, structural-temporal peculiarities of dynamic deformation rock. The main issue I would like to address by the dynamic rock fracture the viewpoint of energy and force criteria formulated from concepts of the structural-temporal approach. We consider effect of water saturation on dynamic strength and dynamic intensity factor. So we compare of strain rate dependencies of dynamic strength and dynamic stress intensity factor. Unlike static experiments where static fracture toughness is a property of the material and a constant value, dynamic fracture toughness depends on the loading history. The instability of dynamic fracture toughness for rock qualitatively repeats the increasing dependence of the dynamic strength of rocks with the strain rate. In both cases, to predict the dynamic behavior of material, the dynamic increase factor parameter is used, which normalizes the dynamic behavior of the material to the static one. Based on this parameter, the rate dependence is approximated in the form of analytical polynomials. The parameter of the analytical polynomials depend on the strain rate, thereby limiting each polynomial to the allowable range of the strain rate. So Ravichandar gave a formula to calculate dynamic stress intensity factor considering the specific crack propagation velocity. To predict rate dependencies of dynamic fracture toughness and dynamic strengths of rocks, we propose to use unique fracture criterion based on incubation time constant. The dynamic fracture of rocks is considered from the point of view of force and energy limiting criteria formulated on the basis of the concepts of the structural-temporal approach. Depending on the characteristics of the material, which are determined by the limiting condition of the moment of fracture, it is possible to set various failure criteria and on their basis plot the strain rate velocity of the dynamic strength characteristics. The structural-temporal approach can be used both for problems of crack propagation and for problems of fracture of initial intermedia that don't a priori contain embedded macrocracks or sharp notches. Using the structural-temporal approach, it is possible to predict the dynamic strength of the rock as a dependent value on the degree of deformation based on the structural-temporal characteristic invariant loading histories. The instability of dynamic fracture toughness for rock qualitatively repeats the increasing dependence of the dynamic strengths of rock with the strain rate. The rate dependencies of the dynamic fracture toughness are characterized by strong instability and can change markedly with varying the duration of the load, the shape of the time profile of the loading pulse, the geometry of the sample, and the way the load is applied. One of the promising models of fracture dynamics is the structural-temporal approach. Time effects observed in dynamic fracture mechanics, including the dependence of fracture toughness on fracture time, can be obtained based on the structural-temporal approach. The behavior of the ultimate stress depends on saturation ratio. The plotting theoretical strain rate curve of fracture stress have a good correspondence with experimental data. We see inversion strange effect. The biggest static strange have dry concrete. The fracture stress above 10 second minus 1 have dynamic strength of wet concrete. This is effect can explained with difference of incubation time of wet granite or dry granite. The incubation time of wet granite is the biggest. The parameters of the incubation time can be considered as a conventional tool to evaluate it and influence of saturation ratio to predict a related effect of inversion of estimated stress with growing loading rate for different materials. The same effect we observed of dynamic fracture toughness of wet and dry marble, and we see plotting strain rate dependencies of dynamic fracture toughness have a good correspond with experimental data, and the biggest incubation time have materials with the biggest dynamic stress, the dynamic fracture toughness. The main feature of the approach is the introduction of incubation time as a property of the material. Its nature is due to the preparatory relaxation processes of the development of micro-defects in the structure of the material associated with macrocracking. The present slide shows that we calculated the incubation time for specimens of granite and coal with different crack lengths tested in three-point bending. It was found that the incubation time does not depend on the length of the cut when testing the samples. This reduces the number of dynamic experiments to estimate the incubation time. The energy criterion for fracture based on the concept of incubation time is presented on this slide. Unlike force characteristic, energy characteristic are the most measurable characteristic for engineers. We decided to compare the obtained incubation characteristic according to the force and energy criteria according to the rate dependencies of the stress intensity factor and fracture energy. The predicted rate dependency of the marble fracture energy during the three-point bending test is shown on this slide. Recall that in order to calculate the theoretic strain rate dependencies, it is important to know the method of loading in the experiment and the static characteristics of the material. A good agreement between the theoretic dependence and experimental data is observed. The incubation time of 86 microseconds calculated from the energy limit condition differs from the incubation time of 34 microseconds estimated from the force limit condition for fracture toughness. The results of estimates of the incubation time from the rate dependence for the fracture work and the rate dependence differ significantly. The result can be affected by the difference in the definition of the moment of time and the method of determining of the characteristic fracture toughness, rate fracture toughness, uh, time fracture and energy fracture. The fracture toughness rate is measured thought the tangent to the stress intensity factor dependencies. The dynamic fracture toughness is determined from the first fracture toughness peak. The fracture time, defined as the initial moment of crack growth, may occur earlier than the peak value of the fracture toughness dependencies is reached. Considering the dependence of dynamic fracture toughness, fracture energy, the limit condition force condition is triggered later than the limit condition of energy. Therefore, the incubation times are different. The strain rate dependence shown is B and D is preferable the dependence because since the fracture time parameter can be determined directly from the experiments, in contrast to the fracture toughness parameter determined from the dependence fracture toughness. And conclusions. The obtained estimate incubation times for coal and granite with different samples cut lengths shown that the incubation time determined by the first criterion does not depend on the sample cut length. The energy and force limiting criteria determined by the structural-temporal approach were used to predict the rate dependencies of the dynamic fracture toughness and fracture lock. The obtained results, according to the formulated limiting power and energy criteria, and carry out on different time scales, since the incubation time obtained according to the energy limiting criteria is longer than according to the power of 1. Thank you for your attention.